In this video I'm going to be dealing with adding and subtracting radicals, which is still our square roots. So with adding and subtracting radicals, we're going to treat this just like if we were to add and subtract variables. So 2x plus 4x would be 6x, just like 2x minus 4x equals negative 2x. Notice I'm not really doing anything with the x except still tacking it on the end, because this is 2x's minus 4x's. So 1, 2 minus 2 of these, so I'll be left with 2 negative x's, which is what this is representing. Same thing with our radicals. So when we actually add and subtract our radicals, say we have 10 square root 11, oops, that's 111. 10 square root 11 minus 11 square root 11. Actually, I'm going to make this plus. Do not do anything with these other than treat them like they are exponent or x's. It didn't change color. Change color. There we go. So if this was an x, I would have 10x plus 11x. Well, I know that's 21x. So just like that, 10 square root 11 plus 11 square root 11 is like saying 21 square root 11. As long as these two numbers are the same inside your square roots, you can just add them like you see them with the numbers in front of it. For another example, if I were to have 3 square root 3 minus 4 square root 3, the numbers under the square roots are the exact same, so I just have 3 minus 4, which is negative 1 square root 3. You can have the 1 here, you can leave it off. These two are the exact same to me. Doesn't matter which way you want to show it. Just know that it's negative 1 square root 3. Now, if I were to do 2 square root 3 minus 2 square root 6, I notice that the numbers under the square roots are not the exact same. However, can I make 6 a square root 3 somehow? Well, let's look at the factorization. It's 2 and a 3, so no, I can't actually make it anything. So I can't actually do it. So that would be your answer, believe it or not. Have to be the exact same under the square root. So for another example, I have 2 square root 6 plus 3 square root 54. That's a 5. Pretend like it is. I have a square root 6 and I have a square root 54. They're not the same now, but can I make them the same? So try to simplify your 54. This will go to 2 and 27. 27 will go to 3 and 9. 9 will go to 3 and 3. So I have a pair of 3's that I can pull out. When you pull these out, multiply the number in front of it. So 2 square root 6 plus, I'm pulling out a 3, but there's already a 3 ahead of it, so this has to be 9, because 3 times 3 is 9. I'm left with a 2 and a 3 on the inside, so 2 times 3 will be 6. So I'm adding 2 square root 6 plus 9 square root 6. Now they're the same, so I can just add the numbers ahead like I see them. 9 plus 2 is 11. That would be your answer. In another case, if there's only 2 of them, and I don't have any numbers ahead or anything like that, say square root 75 plus the square root of 48, I can try to make these, just simplify them as much as I can to try to make them the same thing. So I'll have 2 factor trees in this one. I'll have 75, which I know is 3 and 25. 25 will go down to 5 and 5. With your 48, you have 2 and 24. 24 will go down to 2 and 12. 12 will go to 2 and 6. 6 will go to 2 and 3. So I have 2 pairs of 2 here. I have a pair of 5's here. So with my 75, I'm going to pull out a 5. And I'm still left with a 3 on the inside. Plus, square root of 48 will reduce to 2 and 2. I'm pulling those 2 out. So 2 times 2 is 4. Square root 3 is still left on the inside. So square root 3, I have square root 3 and a square root 3, so 4 plus 5 is 9 square root 3. That would be your answer. Another one, I want you to try this. So pause the video, give it a shot, and then you can watch the explanation. Square root 99 plus square root of 44. Go ahead and pause it. Okay? So if I want to break these both down, try to get them to be the same square root. I know this is 11 and 9. 9 will break down to 3 and 3, so I can pull out a pair of 3's from there. 44 will break down to 11 and 4. I can pull out a pair of 2's from the 4. So this will be 3 square root 11 since I'm pulling out the 3's, and this will be 2 square root 11 since I'm pulling out the 2's. Square root 11 and square root 11, so 2 plus 3 is 5 square root 11. This is the last one I'm going to do with you guys in this video. I have 3 terms here. Do it exactly the same as you would do with 2 terms. If they don't all have the same square root, then you can't add them. But these are pretty big numbers over here, and I might even be able to do something with the 8. So I'm going to see what I can do in just breaking them down. So with the 18, I know that's 2 and 9. 9 will break down to 3, so I can pull out a 3. There's already a 3 ahead of it, so multiply them. So 3 times 3 will be your negative 9. Still have a square root 2 left on the inside. With 8, I know this is 2 times 4. 4 will be 2 times 2. So I can pull out a pair of 2's with a 2 left on the inside here. I'm pulling out 2, but there's already a 3 ahead, so 2 times 3 is 6, with your square root 2 left on the inside. For 24, it's 2 times 12. 12 will break down to 2 times 6, which breaks down one more time to 2 times 3. So I have a pair of 2's that I can pull out of here. What I'm still left with is still 2 times 3 though, which will be 6, so this will be 2 square root 6. Well, notice I don't have all 3 the same, but I do have 2 that are the same. So I can combine these 2, but this one will be kind of all by itself. So negative 9 plus 6 is negative 3 square root 2 minus the 2 square root 6, since I can't combine these 2 terms. That is our answer.